So welcome back. This is the second project in my portfolio. This the title is the trend analysis of 10 popular cryptocurrency. So in this project, I'm using the request library, which is normal Python library used for getting URLs, getting requests from URLs and others. You have many applications, so I'm not going into that. Then I'm using the crypto compare API. So this is their API, cryptocompare.com. This is their API. So I'll be going through what is actually going on here. Now I'm doing it. I'll do it separately for the 10 cryptocurrency which I'll be analyzing. So this is today is actually telling us we are trying to get historical data of what BTC, which is the first symbol BTC, and pairing it to USD. Now this is how the crypto compare pair their own. They also use USDT too, but I just prefer to use USD. I now limit my results to 2000. Now this and symbol is just used to give it different parameters, like many parameters, like for example BTC/USD, and you see it, just many parameters. Now this TOTS is just telling us to give us the end, like where we want to end our data. Like let me just say it this way, like the dates. Now this actually this will end actually on 30th of November 2023. This is in Unix format, so actually it's not human readable, but later on in our data cleaning I will convert that so you see what I'm saying. This our data, it starts from 2018, the second half of 2018 to November 2023, November 30th. Yes, 20. This is the API key, so that is the rest. So this URL 13 is just what I'm using to differentiate many URL, because I'll be working with 10 different distance, so I just use it to differentiate different URLs. So this is the BTC. So I'll not be running this code like I normally do. The reason is this: if I start running the code individually, this video may take long. I don't want it to be too long, but I'll make sure I will keep the code on my GitHub. So in case if you want to also run it to see for yourself. Now this is the response. I want to save it in a variable. So this is the request, which will be request library. So you should get this URL, whatever is in this URL, and save it here. So now try to check what it got, which the doctext attributes or whatever. I think it's attributes here, doctext attributes, and we got this. Wow, this is amazing. So yeah, we're having the data aggregated, or those other ones. I don't think we need that. See, I'm much more focused on this place here, this list of what dictionaries down here. I'm not focused on all these ones above. Of course, I will show you how I was able to bring this sound out. So now in this one, we're having the time, which is also in Unix. I will convert it back in the data cleaning, the high, the low, the open, the volume from, volume 2, and the close. Now we'll be more focused on the close, because at the end of the day, if crypto goes up, down, what matters at the end of the day is its closing price when we want to run our analysis. Now I did this for Ethereum too. The only thing I have to change here is the ETH from BTC to ETH. Everything, other things are the same, and the URL ID and the response ID, and that is all. So I did this for the 10. I also did for Litecoin too. Change it. I'll not be going through all of them. Let me just scroll down at the end of the day to show you how I was able to save it into a CSV file, which we'll be using for data cleaning. Now I imported the pandas library. Then before that, I saved those responses. I converted to the JSON format, because in my first project I actually checked the type. Like I got this and then use the type function to check which type is in. It was when you get your response, it's not yet in JSON, it's still in response, whatever. I think one type. So you have to change it to a JSON. So that is it, .json, and save it in a variable. So now I use these variables here to create a list, which I'll be saving in our data frame, and also create a list of the pairs, of different pairs. because this was not actually in our the data we got from our API. They didn't give us the pairs, but since I did the pair individually, I was able to give them. You see, I was able to separate them to get what I need. So over here, what is going here is I created an empty data frame which we use to save our result. Then I use a for loop. We're having two variables here. We're having two lists which will be looping through. I think that's where we use the zip. Then this I explained this previously. I said that what we need that time was the data. If you rewind the video, what we need is data. Let me scroll up to make it easier for you to understand. Like what we need is not this. We don't need this. What we just need is what? This. This is the data. Then a data inside another data. See, this is the first data. Data is the second data. So if I scroll down to show you what I see, this is the first data. Then the data inside this first data. That's what we actually want to access. Now, if you learn basic Python, this is how you can access, let me say, a dictionary or a list inside a dictionary, like a nested listing. So that's just Python. You can learn more about that later on. Then enhance pass, as I was, this is a loop. So you take this first one, pass it to the data frame, convert it to a data frame. The second one too, convert it to third one, as you did. And also he added this to column 2. Then I appended this into this or bigger data frame or data frames, that is DFs. Then when you are doing this, you're actually having multiple data frames. So I concatenated all of them into the result data frame here. Sorry for this. Then I ignored the index because obviously pandas assign a default index whenever you convert it to a data frame. So I ignored the index when we're concatenating that. It's not needed. But after the concatenation, pandas also assign an index, which is this 0, 1, 2, whatever. So then finally I saved it in the CSV file. I give it a name. And I also remove the index too, because when we're saving the CSV file, we don't need the index. So this is all about the data collection. The next we'll be going to is the data cleaning. Then after that, exploratory analysis, then visualization. So thank you all and goodbye.